Hi everybody, my name is Vesotian and now I'm telling you a little bit about how to make your cars ride softer. And with softer, you can make it with many ways. One way is to install softer springs, softer dampeners, or narrower tires. And here I will go through the physics, how you will get a softer ride with narrower and taller tires. It has also energy consumption benefits, which I have already previous video talk about, but this is more about the ride hardness and impact to that by moving to narrower tires. The Tesla Model Y has 255mm wide tires from factory. If you just install higher profile tires with same width, you won't get much softer ride. It will make it a little bit softer, but not a lot. If you install 195, 205, or even 215 wide tires, you will make it much softer. And here's how it happens. So here I have calculated some tire flexes on the car based on the load and tire pressure. Everything has started from 195/60 18 tire, where I have put 700 kilo load on top, and it was with 3 bars measured this surface patch area, and after that we lowered the pressure to 1.5 bar and then measured the surface area here, and here we get how much it changes if you lower the tire pressure. It's basically the same. If you have an impact on the tire, it will act similar way. And why after that? Then I can calculate how much the surface area is with these tires. I have measured the width sections of these tires, actual tires, which I will test in the Tesla Model Y, and now I have been able to calculate how wide and tall the contact patch is with certain tire pressures, and how it will change based on this pressure formula, that force divided by area, you get the pressure, and that this holy triangle changes, and that's how you can calculate basically roughly how it will happen with certain tire pressure. So with 255 tire, if you lower the tire pressure 1.5 bar, it will flex only 60 millimeter on the Z direction in the car. But if you put there 195/60 tires, it will flex almost double or more than double. No, almost double. So it will flex 11.2 millimeters, which is actually 47% softer ride. Of course, the own suspension of the car already acts on this matter, but on these sharp joints where you drive on the road, dang, 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 this will create a huge improvement in that behavior. If you move to the 205/60 17 tire, which I also have, there the width of the tire, rubber compound width, was actually the same. So it's pretty much the same. It has a little bit bigger diameter, so it flexes a little bit more because of that. So tire diameter of the tire helps also on the flex matter. And here I have calculated also how much tire sidewall each tire has. So the stock tire has 114 millimeter tire sidewall. Then 195/60 is almost the same, only 2.2 millimeter more sidewall, pretty much the same. But when you move to this way, the 215/65/17 has 24 millimeter tire sidewall and 17.9% more in percentage. All of these tires are softer, but some say if you put 235/60 18 tires, it's not changing too much the behavior of the suspension, and then I added this is as a bonus. I will not test this size at the moment, but people said that it's still rough on the suspension, and here's the reason. It's not so much more flex. Here 6mm flex and here 7.7, so 22% more, but in millimeters it's insignificant difference. Of course, the harder the impact, the bigger the differences is, and from that you can estimate what kind of tire will you next get to your car, because its impact to energy consumption is also quite big. I have already tested these 195/60 tires in the Tesla Model Y. Energy consumption savings were about 10% in the first test. Now I will test the other tire sizes you saw there and get more data how they will perform. Accurate braking, moose avoiding tests, slalom, and things like that. Sadly, winter came, so I didn't have enough time to test them on the summer conditions, and now I'm trying to gather some winter tires on the similar sizes and test them on the winter. In winter use, the performance of the narrower tire is almost always and almost all conditions better as a rule of thumb, but we will see how they will handle in various conditions and what the impact will be. What's the purpose of this all testing? I'm designing my own wheels and tires for electric cars, and here you can see excuse me, how my wheel at the moment planned looked is. It will be the lightest aluminum wheel tire combination you can get for your car, and the wheel itself is under 7 kilos looking to be at the moment. So all of these tires will be tested when the road conditions get better, and follow the channel. There will probably come even more videos related to this engineering side of matters. Watch the previous videos. There's also tire stretching video, which you can see because it has big impact also the aerodynamics and the performance of the tall profile tires. Thanks for watching, and keep tuning your cars for better efficiency.